of mature galaxies captured by the Space Telescope over the past decade have been featured in many news reports. However, the appearance of these types of galaxies in a young universe is puzzling many scientists, because they challenge established theories of galaxy formation and cosmic history. Some media outlets even reported that these images overturned the Big Bang Theory. This lacks solid foundation, but these controversies give us a good opportunity to explain what the Big Bang Theory actually says, and there are quite a few surprises. First, the absence of primordial matter. We are often told that the Big Bang is a theory about the creation of the universe, that it explains how the universe could emerge from nothingness and evolve into all the galaxies, stars, and planets. However, that description is only partially correct in its latter part. What we call the Big Bang is merely a theory about the evolution of the universe. The guiding model for cosmology, the inflationary universe, says nothing about the origin of the universe. The birth of space, time, matter, and energy simply isn't addressed. The first version of the Big Bang Theory was proposed by Georges Lemaitre, a Catholic priest. Belgian astronomer and physics professor at the Catholic University of Leuven, Lemaitre made his name by showing that S theory of general relativity could easily help us explain Edwin Hubble. Recognizing the shortcomings of cosmology, Lemaitre went further, proposing an idea he called the primeval atom. At that time, Lemaitre understood a problem that still haunts theories about the origin of the universe. That is the problem known as Kant's first antinomy. 2 centuries before Lemaitre, philosopher Immanuel Kant posed the question: how the universe could be explained through a deterministic cause when it must encompass all causes. Since the universe includes everything, and thus all causes, what could exist outside it to initiate the universe? Lemaitre addressed this problem using ideas from the new science of quantum mechanics. According to his description, all matter and energy were initially in the form of a giant cosmic atom. Lemaitre knew that quantum mechanics had shown that radioactive atoms could decay at any time without a real cause. So Lemaitre argued that the primeval atom solved the problem of Kant's first antinomy by decaying on its own. The products of that decay then decayed into other decay products, eventually leaving all the particles we see today. Of course, this is not the explanation of modern cosmology. T really solved the first antinomy because it didn't. Second, the silence of the universe before the Big Bang. Lemaitre didn't discuss how the universe was formed when debating opponents of his idea. In his view, the primeval atom could exist forever and never decay. Instead, he sought to explain how the universe began evolving into its current state. The indeterminacy built into the very foundation of quantum mechanics allowed Lemaitre to avoid specifying a cause for the universe's evolution. However, he also couldn't explain the origin of that evolving universe. Today, no cosmologist talks about primeval atoms. Instead, they talk about various quantum fields permeating the early universe. But fundamentally, Big Bang cosmology still doesn't describe the creation of the universe. It describes what happens after the moment of creation. It does so with spectacular success, providing a detailed roadmap of how a super ends. And super hot universe expanded and cooled to leave us with everything we see today. The Big Bang itself never tells us where everything originated. If you want to know how the universe was truly created, you need something else, something more. You might want to say the universe has always existed and we're just one phase in a cyclical universe. You might want to conceive of some new, strange mechanism that can create something from nothing. But whatever mechanism you envision, it would be an addition to the Big Bang we have now. Because that theory remains silent on the question of creation. There have been many theories proposed to explain events that occurred even before the Big Bang happened. And the cause that led to the explosion. Quantum physics hypothesizes that our universe may only be a part of a larger universe. This theory formed from observing the cosmic microwave background, CME, radiation left over after the Big Bang. This theory shows that the universe expanded extremely rapidly in the first few minutes after its formation. It caused fluctuations in temperature and density in the CME. However, these fluctuations need to be uniform. Recent efforts to map the universe show many discrepancies, with some areas fluctuating more than others. Some astronomers believe this proves the universe did not form on its own but was created from a larger universe. Another hypothesis mentions giant black holes in other universes. According to the theory, black holes act like giant presses in the universe. Matter, after being sucked in and compressed, is released through a white hole. White holes are the opposite of black holes, acting as release valves for matter and providing energy to it. Therefore, astronomers hypothesize that our universe may have formed inside a giant black hole. And each black hole in the universe could contain unknown universes. Some other scientists believe in the stateless theory. According to it, the singularity formed because the previous universe collapsed in an event called the Big Run. This creates the singularity once again, compressing matter into it and causing the Big Bang to recreate the universe. The process of Big Bang and Big Run then repeats according to the stateless theory. Which came first, the chicken or the egg? Nevertheless, in scientific history, the Big Bang theory remains one of humanity's greatest discoveries. It helps us better understand the formation and development of the universe. Unfortunately, this theory does not clearly explain the origin of the universe. Although there are many hypotheses and theories about the origin of the universe, we still cannot determine their validity. Finding the answer to the origin of the universe remains one of the major challenges of modern space science. Still, with the advancement of science and technology, we hope to have a more accurate answer about the origin of the universe in the future. Until then, let's continue researching and exploring the world around us to understand our life and universe more deeply. Subscribe to the Hidden_Realms channel to watch the latest videos.